Something strange is happening on a moon of Saturn. It is a place where rain falls from an orange sky, but this rain is not water. It is liquid methane, a gas on our world. It fills rivers that carve channels into a landscape of ice-organic sediment, flowing into vast, dark seas. This is Titan, Saturn's largest moon. It is one of the most alien and unsettling worlds NASA has ever explored. Missions sent across 1 billion miles paint a picture both fascinating and eerie. The world we thought we knew, a simple frozen moon, turned out to be a place of active geology, complex chemistry, and liquid on its surface. The voice of this world is quiet. It speaks in data in radar scans and in the few precious images sent back. Cassini-Huygens was our primary messenger. Cassini circled Saturn for 13 years, flying by Titan again and again. One of the most profound discoveries on Titan is its lakes and seas. Imagine standing on a shoreline, not of water, but of a vast sea of liquid methane and ethane. These are hydrocarbons we use as fuel on Earth. On Titan, the cold turns them into liquid. Cassini's radar found huge bodies of this liquid near the poles. Kraken Mare, larger than all of North America's Great Lakes combined. These are stable, deep seas, coastlines, islands, submerged river deltas, sculpted by processes eerily similar to Earth's. The seas drive a methane cycle like Earth's water cycle. Sunlight warms the liquid, causing evaporation. Clouds form in Titan's thick atmosphere. They drift on the wind and release methane as rain, a gentle drizzle, or a torrential downpour. That rain carves river channels in icy bedrock, flowing back toward the polar seas. Scientists have observed shorelines receding and expanding over time. A year on Titan is nearly 30 Earth years. Each season lasts over 7 Earth years. The liquid is frigid. Its viscosity differs from water. Waves are slow and dampened by the thick atmosphere. Across Titan's equatorial regions, vast fields of dark dunes dominate. But these are not dunes of silicate sand. They are composed of solid organic particles that form high in the atmosphere and rain down. Sculpted by Titan's winds into long, linear dunes that can stretch for hundreds of kilometers. They prove Titan is a dynamic world with active surface processes. The most visually striking feature of Titan is its thick, opaque orange atmosphere. This haze is not just a weather phenomenon, it is a global chemical factory. High in the upper atmosphere, about 1,000 kilometers above the surface, ultraviolet light from the sun and energetic particles from Saturn's magnetosphere break apart nitrogen, break apart methane molecules. This is the first step in a complex chemical cascade. The broken fragments recombine into a rich variety of more complex organic compounds, including ethane, propane, acetylene, hydrogen cyanide. This process creates a smog of solid organic particles called tholins. These tholins are the reason for Titan's distinctive color and its hidden surface. The particles are small, but so numerous they create a dense planet-encircling smog that scatters sunlight, bathing the entire moon in a dim reddish-orange glow. From the surface, the sun would be barely visible, a diffuse bright patch in the sky. This haze is not uniform. Cassini's images revealed distinct layers suggesting a complex atmospheric structure and circulation. The tholins are sticky and reddish-brown, and they slowly, inexorably, fall out of the sky like a persistent fine dust, blanketing the entire moon in a deep layer of organic sediment. Perhaps the most tantalizing finding on Titan is strong evidence for a vast ocean of liquid water, hidden deep beneath its icy shell. Data from the Cassini spacecraft revealed Titan's shape deforms as it orbits Saturn. This flexibility suggests its icy crust is floating on a liquid layer. The presence of liquid water, a key ingredient for life, dramatically changes Titan's astrobiological potential. Titan's surface is a geologically complex world with mountains of uplifted ice. But more intriguing is the evidence for cryovolcanism, volcanoes that erupt a cold, slushy mixture of water and ammonia from the moon's interior. These slow eruptions could be a vital link between the subsurface ocean and the surface, bringing materials from the hidden depths and replenishing the methane in Titan's atmosphere. The data from Cassini and Huygens fundamentally rewrote our understanding of Titan. Before, it was a blurry orange ball. Now we see a world of startling complexity, with Earth-like processes under unearthly conditions. We have mapped its seas, traced its rivers, and measured its dunes. Their legacy is a set of beautiful and unsettling questions about the possibility of life. The planned Dragonfly mission is a direct result of those questions. Huygens, a small lander, made a historic descent in 2005. It drifted through thick, nitrogen-rich air for over 2 hours. It gave us our first and only glimpse from inside this alien environment. The images were both familiar and strange. The probe landed in what looked like a dried riverbed. The ground was littered with rounded pebbles, but these were not rocks of stone. They were chunks of water ice, frozen as hard as granite at 179 degrees, 290 degrees. The soil beneath the probe was damp, not with water, but with liquid methane. The sky was not blue, but a deep, hazy orange. It felt like a dream, physics in a profoundly unnatural form. Titan challenges our assumptions about where life's ingredients might be found. Titan has a thick atmosphere, a protective shield few moons possess. It has complex organic molecules raining from the sky. It has liquid on its surface, enabling chemistry. It even has a potential internal energy source. While no life has been found, Titan is a natural laboratory for prebiotic chemistry. Organic tholins could sink from the atmosphere, travel through cracks in the ice, or arrive via cryovolcanic activity. This ocean is a compelling target for future exploration. If pathways connect surface organics to liquid water below, a unique habitat could form at that interface. Where atmospheric chemistry meets the universal solvent, could be a habitable zone. There is no evidence of life, only the tantalizing possibility conditions might be met. What could be swimming in that dark, cold, pressurized ocean, miles below the ice fuel's imagination? Methane and ethane dissolve organics raining from the atmosphere. That creates a complex chemical soup. Some scientists speculate that could be a cradle for life not based on water. It's speculative, but the existence of stable liquids on another world reshapes what habitable can mean. Large seas appear unnervingly smooth in radar, dark panes of glass, the sun a dim bright spot in haze. The juxtaposition of the familiar and the alien is what makes Titan so unnerving. The shorelines look real, but the sea is poison. The pebbles look real, but they are made of ice. It feels like a place waiting for something, a stage set for a play that has not yet begun. The findings from Titan are terrifying, not because of monsters, but because they reveal the vast, cold, and creative indifference of the cosmos. Worlds can follow their own strange logic, beautiful, complex, and utterly hostile to us. The silence from Titan is not empty. It is full of chemistry, geology, and possibility.